good day to everyone. So I'm Jomar Liquido from Apo University, Philippines. So allow me to present to you my research output entitled Design and Development of a Master Slave Algorithm for Agricultural Mobile Robots. So in this slide, this is the outline of my presentation. So let me start with an introduction. So farmers are necessary for agricultural sector because they provide for the essential needs of the people. So with the advancement of the technology in every field of industry, people nowadays are also advancing towards the current trends in the market. But there are still some setbacks, and that is in the fields of agriculture. So the unavailability of the workforce and lack of new farming methods have caused a significant decline to support the production of any agricultural products. A solution is to utilize robotics by implementing multiple mobile robots of doing multi-operations for farming applications. So for the supporting literature, according to Noboru Noguchi, to supervise a group of robots, so there are different approaches used to deal with formation control problem. So the application of the master-slave approach can be used for multi-robot, where one robot will act as a leader robot and the others will be the slave robots. Other related studies where the master-slave robot can be teleoperated using an Android smartphone via Bluetooth, where the master robot is connected wirelessly to the smartphone and it will rebroadcast the command signal to the slave robots. So for the gap or missing information, so some farming tools use only a single vehicle or a robot to accomplish a certain task. And then some proposed methods for the farming operation were dedicated only to a specific task. So the main objective of this work is to design and develop a group of homogeneous mobile robots that can autonomously perform farming operations such as plowing, seed sowing, soil closing functions now by setting the desired value of each parameter, such as the row position, the composition, the depth of soil, as well as the number of seeds to be distributed in the field. So for the methodology, so we have four phases. First, we have the system design, the system algorithms, building and testing the prototypes, and lastly, the data analysis, data gathering and analysis. So under the system design phase, so this involves planning and design of the system, like the technical review of the different electronic modules, structural design, as well as the hardware schematic design. And then under the system algorithms, so this involves creating layouts of the graphical user interface or the GUI, the master slave algorithm layout, the kinematic-based motion control layout, and lastly, we have the agricultural mechanisms. And then for building and testing the prototypes, so we have, this involves hardware and software integration, unit and functional testing, integration testing, as well as the overall system testing. And lastly, for the data gathering and analysis, so this involves collecting data, statistical analysis, and discussion of results. So for the conceptual framework of the project, so for the input, commands from the user via the mobile app, and the speed sensors embedded in the system, which measures the speed of the robot. And then for the process, so the Arduino Mega controller was used to control the overall processes of the system that controls the grid as well as the servo motors, and also responsible for controlling the communication devices such as the Bluetooth and the Zigbee modules. So for the output, controlling the different agricultural operations like the plowing, seed sowing, as well as the soil closing, no? And also the movements of each robot. So for the actual test was conducted in controlled as well as uncontrolled environment, and the type of soil used was light and loam sandy soil. So for the controlled environment, the researcher built a miniaturized garden made up of a plywood, which is enough to hold the soil. And then for the environmental factors such as uneven grounds, stones, etc., were not employed in the miniaturized garden for the purpose of obtaining experimental data. And then for uncontrolled environment, the multiple mobile robots were positioned in an actual garden with an area of 2,400 square centimeters. for obtaining experimental data as well. And then the peanut seeds were planted during the actual test process. So necessary data, such as the parameters, as I had mentioned earlier, we have the row position, column position, the depth of soil, as well as the number of seeds to be distributed, were gathered and then subjected to t-test statistical analysis. So the purpose of the t-test method was to validate if the obtained main scores of the parameters are equal with the desired main scores of the same parameters. So for the null hypothesis, so the obtained main scores of each parameter are equal to the desired main scores of the same parameters. While for the alternative hypothesis, so the obtained main scores of each parameter are not equal with the expected mean of the same parameters. So let's proceed with the data analysis and results. So based on the table 1, so as you can see, the analysis of results revealed that there's no significant difference in the main scores of the parameters for the desired as well as obtained main scores. So the p-values of each parameter were greater than the significance level of 5%. So this result suggests that the null hypothesis was accepted, thereby indicating that the 3 robots were accurate and effective for farming operations. Okay, next. Based on the table 2, so as you can see in the table now, the analysis of results revealed that there's no significant difference in the main scores of the parameters, especially for the desired as well as obtained main scores, except for a single parameter. So which falls under the second robot, so which is the depth of soil, which had a p-value below the significance level of 5%. Okay, but if you look at the table, the difference between the main score is small. Okay, where the desired value is just only 2.5 centimeters, while the obtained value is 2.45 centimeters. So this result suggests that the null hypothesis was still accepted. Okay, so thereby indicating that the 3 robots were accurate. So for the conclusion, so the researcher was able to implement semi-autonomous multiple mobile robots that can be used for agricultural farming operations. So the master-slave multiple mobile robots with kinematic-based controllers and farming mechanisms were utilized to conduct a repetitive farming task, such as plowing, seed sowing, as well as soil closing actions. And then the effectivity of multiple mobile robots in doing the farming task is based on the performance of the motion controller and to achieve the objectives of the study. So the applications of multiple mobile robots for farming operations will provide a lower cost for manpower expenses and also help to increase now the productions of any agricultural products. So based on the quantitative analysis of the experiments conducted in both controlled as well as uncontrolled environments, it can be concluded that environmental factors such as uneven grounds, soil quality, as well as the weather are some of the important factors to consider when designing and developing a robot for agricultural applications. Okay, so thank you for listening to my presentation, and that's all from my end. Once again, thank you.
Thank you for your wonderful presentation.